Hello everyone, welcome to OpenStack Vancouver. Vancouver is my hometown, so I'm pleased to see everybody here. My name's Sig Luft. I'm the CTO and co-founder of Ciaris, I should say. We're going to talk about OpenStack as an Uber cloud, or a cloud on top of a cloud. And Ciaris is currently completing development of this product, and we're launching it at the bottom of the year with one of our customers. So I'll go over a little bit of the concept and then walk you through some of the actual use cases that are being deployed. So our product is called Cloudscape. It's essentially a platform that exposes a variety of federated clouds together as one. We also pay close attention to the connectivity that's needed. So when you're looking in a cloud environment, you'll be seeing data centers that can be deployed in a multitude of locations, and those data centers may actually want to be in different types of clouds. If you have two applications that are working together but in distant locations, connectivity can often be an important piece, and this is why we have that component in our system. So starting at simple concepts, this is just a standard OpenStack picture where you have compute network storage. What's interesting is that you come in, you deploy your application, you run it, all is well. OpenStack does a really good job of bringing a lot of vendor capabilities into the system. And the other piece that you're interested in is the ability to monitor how your applications are running. As we look at a slightly more complicated picture, where you may in fact be running in different locations and in fact need different networking resources, you suddenly have this issue of having to deal with a variety of APIs, a variety of policies with different vendors and services. And this becomes fairly onerous to the application developer. So Ciaris has come along, and what we've essentially done is we've created an OpenStack platform. And this OpenStack platform rides on top of a variety of clouds. What the application sees is one OpenStack. It has a few extensions that allow you to pick different, what we call underclouds, to perform the role needed as an infrastructure platform, but it is all visually seen in one place. So we have a concept of stateful management. It allows the applications to all be monitored and orchestrated and billed for, if that's the case, in one place. We've also introduced a concept which we call WAN services, or WAN neutron WAN. And really the concept here is when these different data centers are being connected together, there's really no good way today in OpenStack to expose that to the user, to the developer. And so what we've done is we've created a new type of project. And really the concept is if you're on the left-hand side and you want to connect to the right-hand side, today you're really only limited to creating a ML2 interface or other, pointing left and right, but you don't know what's in the middle. What the Neutron WAN project is intended to do is to allow you to orchestrate elements in the middle. As well as this, if we do one animation here, the other motivation of going with OpenStack is that there's a growing community around OpenStack. And so by dealing with the development environment as something that sits on top of OpenStack, we can divide and conquer in terms of roles and responsibilities in environments where multi-cloud is being used. So in this particular illustration, the person in charge of deciding who can go where and when in this fabric of clouds can be illustrated or can be orchestrated by the IT group, and the DevOps guys can go freely and develop a number of applications on top of this and not worry about where I'm allowed to go or not. It'll be all accessible through one interface that is defined by the IT operator or administrator. So we're going to quickly go and just run through some snapshots of a real deployment. Our partner in Tokyo has a number of private clouds as well as is exposing a number of public clouds. What we see on the screen here is on the top right here, a number of projects that are mapped to different physical data centers. Some are public, some are private. And this gives the user the ability to take a look at all of the assets at their disposal. You can see on the left here, there's a CRs tab that we've added to Horizon, and this is where you can do a number of these functions. If we take a look, one of the elements that we've integrated in is Salamat. So we have a common Salamat interface regardless of where your resources are deployed. So here we can see inside AWS Tokyo, we have a number of instances, vCPUs, and so on. The same applies whether it's a VMware footprint, an OpenStack footprint, or even a soft layer footprint. This gives us a view of our perspective of 3 servers that are currently running inside that AWS instance. You can again see at the top where this instance exists. And this is our OpenStack looking at those 3 instances. It maintains a stateful view of it. The instances themselves are actually running in AWS, and if you were to log into AWS, you would see a reference to those 3 instances. We do this because this allows us to maintain a stateful view of the intended deployment as well as what's actually happening inside the undercloud. This is now another picture of the same deployment on AWS. What's interesting here is we've also deployed a load balancer. So we've abstracted LBAS as a generic OpenStack concept, and we map it into Amazon, VMware, soft layer, and of course OpenStack. Excuse me. And so this allows the user of our platform to define the constructs for the virtual data center, whether it's complex or simple, and define it once and deploy it in different types of underclouds. This is just a quick snapshot of the LBAS. Again, just using the standard OpenStack definition and APIs. We map it into what is underneath. In this particular case, we're round robining amongst 3 servers. We've done the same with firewall as a service. So this is on our VMware environment. In this particular example, you can see up here, we have 3 servers, and we've created a perimeter firewall using underneath a Viyata firewall. This, again, is one firewall as a service definition that could be applied to Amazon, could be applied to all of the other underclouds that we currently support. And here's a snapshot of the definition. So this would allow again, the security person within an organization to define a standard firewall definition. And then as different deployments occur in different footprints, you would have one definition that you need to worry about. We do some interesting things to make this work on Amazon, for instance. They use control lists to perform the function. And there's things between VPCs that kind of break things. So we do a little interesting munging of the ACL so it actually works as a perimeter firewall. So finally, I'm just going to illustrate how we can federate between these 2 sites. We said that we are interested in not only creating this footprint, but also connecting the different virtual tenants. So in this case, we go to a new tab that we've created. We call it the WAN tab. And this can either be mapped into just a VPN service, or it can be mapped into an underlying networking assets. In the case of our partner in Tokyo, they actually have a Metro Ethernet fabric, and we can tie their network into direct connect services. So you could have your own virtual network connection from a project in a VMware footprint through to a project inside Amazon. So the way we do this is we first create a new project, and we give it a name. In this particular case, we said we would like 125 megabits per second, and we've given it a subnetwork for which we're connecting the 2 sites on. We then go to one of the projects, and we selected, in this particular case, a VMware footprint in, I'm not going to try and pronounce that, but it's a backup site in this example. And we've picked the private network. So this will be a private IP address connected to a private IP address. It won't be visible to the outside world. And on the AWS site, we again chose the private subnetwork, so it'll be a 10.100 to a 10.100 type of connection. We would come through here, or in this particular example, and we save the connection, and it will actually trigger the deployment. This particular example that we're showing, we actually created underneath a VPN between the two sites. But in a future iteration of our software, we will actually orchestrate a dedicated E-line service to an Equinix exchange point, and at that Equinix exchange point, we'll put a cross-connect in and allocate a VLAN on a direct connect circuit into the appropriate Amazon data center. When we take a look at this picture or go back to the mapping view of this, we now see that there is a connection between the two sites, and we can, of course, drill in and do all of our analytics and so on. So this actual component here is the manifestation of this Neutron WAN project that I identified earlier. And of course, the VMware and the Amazon footprints are manifestations of two different projects over top of two different clouds. They're all seen as OpenStack. They all act as OpenStack. And to the extent that Neutron WAN is a new concept, we believe it's in spirit developed the way OpenStack will eventually pursue this. So that gives you a quick overview of what we've done and how we're going to the market with our product. We'd be more than happy to explain more about what we're doing, and please give us a call. Our website is www.ciaris.com. Thank you.